All right, this is a walkthrough or demonstration of how to construct a parallel line through a point not on a line. So from our picture right here, we would want to construct a line through point M that was parallel to line KL. We just discussed a postulate 13, that said if there is a line and a point not on the line, then there is exactly one line through that point parallel to the given line. There are infinitely many different lines that will go through any particular point. And remember, these lines all would have to be on the same plane to even have a chance of being parallel. You can't have parallel lines without them being coplanar. But none of these lines are parallel to the line below that we see. Only one line will be parallel to that line below. And the question is, how do we construct that line? So here is the construction. Let's go ahead and go through this. We're going to go ahead. We're going to be given a line, and we're going to be given a point that's not on the line. So our line is KL, and our point that's not on the line for us is point M. The first thing we're going to do is we're going to use our straight edge, and we're going to draw any line through the point that's not on the line, so that's point M, that intersects the line that we want to be parallel to. Make sure that this line extends past the point not on the line. And that's because later in this construction we're going to need additional room. So I'm going to go ahead and grab a straight line that would act as my straight edge. And I'm going to come from up above the point down through the point, and then as it says, it doesn't matter where you intersect the line. You just have to intersect it somewhere. So I'm going to go ahead and use that line right there. And any line like that, no matter what angle it's intersecting at, would work perfectly, okay? That's step one. What we've done, though, is we've created an angle. And we didn't have an angle before, and now that I have two lines crossing right here, I've created an angle. And that's really what the rest of this construction is all about, is using that angle to our advantage. What is the next step of this process? Well, we are going to make an arc through the new angle we've created. Your two lines have created an angle, and we're going to use our compass to create an arc through both sides of our angle. So I'm going to go ahead and grab our protractor here. Get it set up at the vertex. Doesn't matter what arc length you use. It's really up to you. I wouldn't make it too small or too big, just a nice distance somewhere in between. And then go ahead and make that arc like we've been accustomed to doing when we're doing the other angle constructions from earlier. Okay, so step two has been completed. Good deal. What we're going to do now is we're going to go up to that point that's not on the line, that point M. And we're going to use that same exact arc length that we just used, that same exact radius, and we're going to extend an arc from point M. We're going to make sure it crosses the line that goes through point M. And as it says, make sure you extend this arc long enough that it would pass through a line parallel to the original line. So I'm going to go ahead and move this up. I'm going to put the vertex at our point M. And I don't know where the parallel line is exactly. It could be kind of here, maybe a little bit higher, maybe a little bit lower. I mean, we're not exactly sure. That's why we're doing the construction. But I do know that at least in that vicinity, at least somewhere in this area right here, that line's going to be passing through. So when I draw my arc, as the direction said, I'm going to make sure that that line just appeared again. That was kind of like magic. I'm going to make sure that I arc low enough that I would for sure go through where any line would pass. Okay. No matter where we drew that line now. No matter where we ended up drawing that line, it's going to pass through that arc. And that's all that means when you make your arc long enough so that it would extend. That's the story there, okay? So here's what we've got now. I'm just summarizing the first 3 steps. Make a line that goes through the point and through the line itself. Then we make an arc at the angle that we created, and then we go up to the point that was not on the line, and we make that exact same arc. That's where we are. Okay, let's see where we go from there. Now, using your compass, measure the distance between the arc and the intersection point on the angle below. So, if this seems familiar, and I hope it does, it's because this is the exact same process we used earlier in the semester on a different construction. So if I want to get this distance right, I'm going to have to go out just a little bit further with the compass. There we go. That's about it right there. I like to make a little arc just to prove that I've been there where I was supposed to be, but that's the distance between the arcs. So now I know this distance, and the very next step, I'm going to take that distance, and I'm going to go up to the arc that I created. The arc above only has one intersection point, but I'm going to put the compass point on that intersection point and then arc another intersection point through the arc. And so that would look kind of like this. Here we go. First thing I'm going to have to do is I'm going to flip the orientation because my arc intersection point is up above. And now I'm going to go ahead and slide that through. Okay? That creates a new point right here that is the intersection point of the 2 arcs. And if it seems like this is very similar to the construction where we copied an angle, you're exactly right. It looks a little different because we did one arc kind of up and then the other arc kind of went down below, so the lines aren't oriented in the same position to start with, but that's pretty much it. And in fact, if we complete this construction by drawing a straight line through the original point M and this new point we created in the directions it says we would call this point Q, which is fine. We can go ahead and call this point Q. Okay, but if we use our straight edge and we go through those 2 points, let's see here, just like so, right? We've created a line that is parallel to the original line. And the reasoning behind this construction has to do with the postulate that says that when a transversal, and our transversal is the line that we drew down in step 1, crosses 2 parallel lines. Those are our 2 parallel lines, that the corresponding angles, and so this angle right here corresponds to this angle right here, are congruent. And then the converse of that postulate tells us that if a line crosses 2 lines, if a transversal crosses 2 lines, creating corresponding angles that are congruent, then those 2 lines would have to be parallel. And so because I created these 2 angles right here, because I created these 2 corresponding angles that are indeed congruent to each other, that means that the lines themselves would have to be parallel. So this one is a little bit longer construction. If you practice it a couple times in a row, though, the steps start becoming pretty obvious, or at least more natural. You draw a line from the point through the line, you create an arc, you create another arc up above, you measure the distance between the arc below, you copy that distance up above, and that creates a new point, and you draw a line from your original point through that new point, and that creates a parallel line. The reason it works is because of the corresponding angles converse postulate, and that is construction 5. Parallel line through a point, not on a line. Thanks for watching.